You know, the electric vehicle revolution is so much more than just a quieter ride and never having to go to a gas station again. It is a massive technological shift, and it is packed with complex choices and really fascinating trade-offs. So let's pop the hood on our electric future and see what's really going on. So why is all of this happening right now? Well, the heart of the matter is this. Our transportation system, we're talking cars, trucks, planes, you name it, is the single biggest source of greenhouse gas emissions in the entire US. And to put a number on that, we're looking at a full third of all emissions. I mean, think about that. That is a huge slice of the climate change pie, and it's a problem that really demands a powerful solution. And the big solution on the table? You guessed it, electric vehicles. They're being positioned as our main weapon in the fight to decarbonize transportation. The promise is pretty simple, right? Swap the tailpipe for a plug and help clean up our air and our planet. And look, this isn't just wishful thinking. There's a real national strategy behind it. Let's dig into the ambitious blueprint that's been drawn up to turn this electric promise into a reality. The US has set some incredibly ambitious targets just for this decade. They want half of all new cars sold to be electric, they want a network of 500,000 chargers built out, and the plan even goes after aviation emissions. This is not just a suggestion. This is a serious, structured national project. But, you know, to hit those goals, it all comes down to the tech inside the car, specifically the battery. And right now, there is a fascinating battle of chemistries playing out, a choice that has huge consequences for everything: cost, ethics, and performance. So on one side, you've got LFP, that's lithium iron phosphate. You can think of these as the cheaper, safer, and longer-lasting option. Then, on the other side, you have NCX batteries, which get their name from the nickel and cobalt they use. Now, these pack more punch, more energy into the same space, which means more range, and those valuable metals inside create a really big incentive to recycle them. This quote from a user on Reddit really gets right to the ethical heart of the whole thing. A huge, huge selling point for LFP batteries is that they completely avoid using cobalt, a mineral that's, notoriously linked to some serious human rights abuses in its supply chain. So if LFP is cobalt-free, why use NCX at all? Well, it really comes down to performance and economics. That higher energy density is exactly why they're used in the long-range versions of cars you've definitely heard of. And the fact that the raw materials are so valuable means there's a clear, profitable reason to recycle them when they're done. But with any lithium-ion battery, there is an inherent risk that every manufacturer works tirelessly to prevent. It's called thermal runaway. And this is what it looks like when things go catastrophically wrong. This breakdown shows you exactly how that chain reaction happens. It all starts with what's called battery abuse, some kind of trigger, like overcharging or maybe a physical impact. This causes the battery to off-gas, which releases flammable vapor. That leads to smoke and, finally, fire. And here's the critical part. The intense heat from that one failing cell can set off its neighbors, creating that dangerous cascade effect we call thermal runaway. Okay, so this brings us to an even bigger question. Beyond the sticker price and, the fire risk, what is the true hidden cost of an EV? This means we have to unpack some really complex economic and ethical issues. So choosing a cobalt-free LFP battery seems like the obvious ethical choice, right? Well, not so fast. As this user points out, the L in LFP still stands for lithium, and the lithium mining industry faces its own serious allegations. The takeaway here is pretty clear. There are no simple, perfectly ethical answers in this game. And you know what? The economic picture is just as complicated. A key concept to understand is second life value. This just means that even after a battery can't really power a car anymore, it might still have years of useful life left, say, storing energy for a house or for the power grid. And this is where the two battery types go down completely different economic paths. LFP batteries with that super long lifespan are perfect for a second life. They can hold on to up to 40% of their original value for use in home storage. But there's not much of a financial reason to recycle them. NCX batteries? Totally the opposite. Their valuable metals mean there's a big payoff for recycling them right away, but way less reason to give them a second life. Two very different futures for these batteries. All right, so we've looked at the policy, the tech, the economics. But how do all these high-level trade-offs actually feel in the day-to-day? The experience of driving and living with these cars. Let's take one really hotly debated example. Tesla's decision to get rid of the turn signal stalks and put buttons on the steering wheel instead. As one critic on Reddit puts it, This feels like fixing something that was never broken in the first place. But then you hear from a long-term owner who basically says, yeah, once you get used to it, it is a total non-issue. This just goes to show you how divisive these design choices can be. What one person sees as a major flaw, another sees as an innovation they can just adapt to. And this user, I think, really nails the core of the whole debate. Was this change made to benefit the driver? Or was it mostly to benefit the manufacturer by simplifying production and cutting costs? It's a tension you see playing out over and over again in this industry. So, with all these complicated debates about the tech, the ethics, the user experience, how do we actually move forward? Well, let's zoom back out to that national blueprint for a second. The path forward is this massive coordinated effort. This isn't just one agency's pet project. We're talking about the departments of energy, transportation, the EPA, and even housing and urban development, all working together on one unified strategy. And that strategy has a really clear timeline. This decade, the 2020s, it's all about laying the foundation. The 2030s are about hitting that critical 50% sales target and really scaling up manufacturing. And then the 2040s are about finishing the job, getting the last of the gas-powered cars off the road for good. So the blueprint is drawn. But as we've seen, every single step forward involves some kind of trade-off, right? Performance versus ethics, cost versus convenience, a carmaker's goals versus a driver's experience. So the final question isn't just for the engineers or the politicians. It's for all of us. What compromises are we actually willing to accept to build this clean transportation future?